So I'm an engineer by training, but when I started picking up the clarinet again in my late 30s, I was fortunate enough to study with Larry Guy. And because I'm always tinkering with stuff and wanting to understand it, I started working on my own mouthpieces, and he sent me to work with Everett Matson down in New Jersey. And the one thing that struck me was that Everett did a lot of stuff by feel, not by measurement. And so the reason I'm making this video is because being an engineer, I want to measure, understand, make a change, measure afterwards, see that I did it correctly. And so I developed a tool set and a bunch of things that I use that aren't standard in the industry. I like using a machinist's V-block for holding my mouthpieces while I work on them. It makes it very steady. I like using a diamond plate, which is absolutely flat, flatter than you can get any piece of sandpaper on glass. I use, to measure tip opening, I use pin gauges, which are far more easy to use and more accurate than feeler gauges in the thicker ranges. I do use feeler gauges for the smaller size. In addition, you need to invest a lot in various Swiss files and all sorts of different shapes. From one that's extremely coarse to go in and remove material. Everett used to use what he called a hoe, and he had these things fabricated by machinists that had a curve, and then he would just scrape the mouthpiece, which is good, but it removes a lot of material, and you don't know, which part of the material you should remove. And so I've developed a measurement technique you're going to learn about in this video for that as well. Am I saying this is the only way to work on mouthpieces? No. But it's one particular way. I'm reaching the end of career here, and want to pass the knowledge I've learned on. So if some of this is helpful for somebody, terrific. I don't recommend you start working on your own favorite mouthpiece to change it until you've destroyed at least 10 other mouthpieces that you've purchased on eBay that you can afford to destroy and not feel badly about it. But there are plenty of old mouthpieces out there that are great candidates. For rework, older Selmers, Bundys, you name it, there's a bunch. In general, the older the better. It turns out that rubber is off-gassing for about 20 years, vulcanized rubber. And so by the time a mouthpiece gets to be about 20 years old, the material is pretty good. It's glass-like. And I think that's what makes a nice sounding mouthpiece. And so with that, I'm going to dig into the rest of the video. And again, this is one way, but I've developed a tool set that I think is helpful, and it may be helpful to somebody else. And at least all this stuff that I've learned over the years won't disappear when I do. So talk to you soon. So this is a mouthpiece I'm considering restoring. Excuse my cold here. It's a George Bundy, made in France. Hideously grungy on the inside, but before I do any work, I'm just going to make a couple of measurements to make sure it's within spec, so to speak, that it will play relatively in tune. So I'm going to measure the width of the window here to make sure that it will be able to be focused when it plays. It can't be more than 11.5 millimeters. And the diameter of the exit bore here, which will indicate how low the pitch might be. Because I don't have enough hands, the window width was 11.8 millimeters, so that's plenty narrow. We'll have to widen it, in fact. And the diameter at the bore is a little large. In fact, it's looks like it is 15, so that's 15 and a half plus 14, so that's 15.64 millimeters. So let's see, I'm going to clean it and then we'll play it and see how low the pitch is before I continue doing any work. So to clean this, I'm going to use some decalcification stuff used for espresso machines. And just because I'm next to my espresso machine, there's some soap that's used to clean espresso machines. And I'm going to put it all in a glass here that I brought home from Claire Hammond's wedding. So we'll put in it's like a good half teaspoon of this. Put in some of the soap here. Stir it all up. And we'll let this puppy soak overnight. Okay, we're in the Clarinet mouthpiece bathroom here, and I'm going to take the mouthpiece that I was soaking. It's soaked for 24 hours, and I will brush it with a mouthpiece brush. Brush here, clean here and here.
Your hand is covering.
That's my kind wife who's holding the video for me. And that's it. Fairly clean. If it plays in tune, I will then show you how I resurface the mouthpiece so that it all looks the same color and gets rid of some of those scratches. Normally I use my cell phone tuner app. Here's the mouthpiece that's been cleaned that I plan on restoring. I'm going to just check the tune with my standard mouthpiece that I use, an old Selmer HS Star oval. Typical, just a little flat around throat G and F. And now we'll try the other mouthpiece. So I'm going to take this puppy off. And put this mouthpiece on. I put cork grease on it because that washing got rid of all the cork grease. And we'll line this up. And some people think you shouldn't slide a reed into a ligature because it sands the surface of the table. I don't know what you guys think. That's quite some sound, but it looks like it's in the range. So if anything, it might be a little sharper. That's terrific. So the next step is going to be to remove quite a bit of material from the table here in order to work the, so that when I put a facing on, we've widened the rails quite a bit. In other words, moving the rails out into this section of the mouthpiece cone. That will give me enough material to remove from the inside of each rail here, because these rails measured only 11.1 millimeters edge to edge, and you really need about 11.4 millimeters to get the freedom you want to feel when playing a mouthpiece. But the pitch looks okay, and so next I will work on that table, and we'll go from there. One of the other measurements I check on a mouthpiece is the level of perpendicularity between the table surface and the side walls. I've seen some mouthpieces in the field that have extremely crooked setup. So here I check the right angle. I've got the crossbar firmly on the table. I see the amount of gap below on one side, and I look at the gap on the other. And if they're fairly equivalent, I don't need to compensate by removing one side more than the other while I'm planing the table down a little bit. So this looks good, and we'll continue with a straight removal of material. And this may look harsh, but we're just going to take a stroke or two and then move to a diamond plate. By the way, it's typical that you see this area is lower than the rest of the table on mouthpieces, early mouthpieces. I'm not sure why. Okay, we'll do the rest with a diamond plate, and I'll show you in a second. I use two different types of diamond plates. These are extremely flat, available from Easy Lap, but extremely expensive. They used to be $70 per piece, and I have coarse, medium, and fine grit. And then these are not so expensive. They come from Temu, but they're so thin that I've mounted them with double-sided tape to a piece of plate glass. And so that's what I'm going to use. So basically, a motion like this. And again, don't press so hard, because when you press hard, the friction will cause tipping one way or the other. And then, sorry, this way. Then straight away. Okay. In order to get the table extremely flat, my preference is for the fine grit large steel, and only stroking in one direction. Again, relatively lightly. And then if you take a couple of strokes with the very fine, you'll be able to see if you have any low points. And it looks like we're connecting all the way up along the table, all the way up to here. And so the only thing I'm going to do now is check the amount of separation, see if we have enough to put a new tip on there. This is 040 pin gauge, which is, still going down quite a bit. So that mouthpiece would be too open for me anyhow. So what I'm going to do is I'm going to redo all that sanding operation again until I get the tip opening less than 0.040. Back in a bit. Okay, we're back. The tip opening is definitely less than 0.040, and I just check the flatness of the table by looking to see if I can see any light between a straight edge, and I'm going to try to tip this up and create some confusion for the lens here, but in fact, there. I don't see, whoops, don't see anything. And these straight edges, by the way, high quality ones, Mitutoyo you can get on Amazon. I think they're like 13 bucks, but definitely worth it. Also with millimeter markings, so that in a pinch you can use them as mouthpiece gauges, even by putting the mouthpiece down on here and then sliding your feeler gauge down and see where it stops. Anyhow, looks like we're flat. The next step is going to be starting to take off material starting at the tip. What's interesting about hard cast rubber mouthpieces, and even if it's cut out of a solid core, the core was cast at one point, is that when the rubber cools down, it all falls under tension. So all the fibers are tense, especially on the outside of the material. So if you remove a bit here, what was balanced tension between this side and that side as it cooled now becomes unbalanced, and this side will start to pull away a little bit. And so you have to be careful as you start to put a facing on a mouthpiece that you're not too aggressive. You take a little bit at a time, and you'll see the mouthpiece will gradually fold back like that on you. So you undershoot all the way along until you get to something close. You let it sit overnight, and then you try approaching it the next day, also working from the tip toward the bottom. And so we'll start that process next. Everybody has their own favorite way of measuring a mouthpiece table. I like to use a combination of feeler gauges. So this is 0.001, and this is how far down I like to see them go, the bottom number. If it's a short facing, the top number. But 0.001, 0.005, 0.010, 0.015, 0.020, and 0.025. And then I use, for thicker measurements, pin gauges, starting with 030, and then I use 032, 035, 038, and then this should be the tip opening is 040. And in the comments below, I'll let you know how far I think these should be going down in order to get the best type of resistance for a concert, orchestral mouthpiece that is close, but not too close, and a long facing, so you use a hard reed that gives you a good core to the sound. I made my own glass plate, but there's also one I use from Theo Wayne. I'm not sure how to pronounce that last name. And basically, what we're going to do, I have one side that the mouthpiece goes on where the markings are. I line up the very tip of the mouthpiece with the 0th measuring part, and here's my 040. So I'm not going to open it all the way to 040 to begin with. See, it doesn't go in at all. But I'll take a stroke and show you how I do this. So these diamond stones are 120 grit, 240 grit, 400 grit, and 600 grit. And in the beginning, I'll use between the 240 and the 400 mostly. And I put my hands on the each side, my fingers on each side at the level that I want to operate, and will always take a slight arc as I pull. And that arc ensures that there are no flats on the rail as you're making the rail. And notice here that it only made marks here and here, not on the tip rail at all. And so that means that this tip rail was concave that way, which is typical. Only now am I making a little bit of headway into the tip rail. And actually, the only place I do like a teeny bit of flat is right there at the end. It just adds a little slap and color to the sound. If you continue a radius all the way through the tip, you will not be able to get any excitement in the sound, in my opinion. So we're still far away. Here we go. Okay, now, see, I've had a coffee. So now, this one, the 038, I like to see go down 1 millimeter. It's a little shy. That's okay. I'm going to leave it there for now. 035, I like to see it go down 2 millimeters, and it's far down on the right and not so far on the left. So all I'm going to do is remove a little bit of space on the left. Oh, by the way, what I do is I line up here and I put my fingernail literally right where the 2 millimeter mark is on each side. And now I'm only going to press down on this finger. I'm not pressing down on this finger at all. I'm taking a slight rolling motion as I drag the mouthpiece. And now we come back. And we're going to measure that again. And okay, it's lying flat across. And it's still above 2.0 millimeters, so that's good. I don't want it to go all the way down because I know this guy's going to peel back the more I take down. This should go down to 3, and it's just slightly above 3. I'm going to leave well enough alone for now, and we'll come back. And 030 should come down 4 millimeters, and he's squarely at 3, so I'm going to just put a little on there. So I'm going to put my fingernail on the 4 millimeter, and I take, and I'm only pushing down on my fingernails, and I roll just a little bit. I don't want any flats. Okay. Still very high. He's all the way up at this, but it's a little lower on the right, so I'm going to take a little more on the left. 4 millimeter. Press down with this finger, not this one. Oops, sorry. Okay, so we're still at 3. I'm just going to take a little more now that I can take it evenly on both sides. And you learn how many strokes you have to take at a particular grit. And toward the tip you take very few strokes because there's so little material you're removing. We're down at 3, almost 3.5. And I do this little by little because you can always take away, but you cannot put back. Five. There, it's about 4.5, so I'm going to leave that. And now we're going to move to the feeler gauges. By the way, the tip gauges are great for bass clarinet mouthpieces, and I have a whole other kit that gets thicker than 060 for saxophone mouthpieces. So here, ooh, we are already, how can that be? We're already at 6 there. So I'm not going to do anything there. This guy, okay, we're way below on 8. When I put in this guy, he only goes down to a little more than 6. So, you know what? I'm going to wipe the bottom of this, and I'm going to wipe this. We're going to remeasure that 5 to 6 guy here. Ah, there we go. So there was a little piece of dirt in there. So he's down at 5, and so I'm going to take a little more off of here till it goes down to 7, because then by the time I'm done, they'll all peel back. So I put my fingers where it says 8. And it's going to go like this all the way down. I'm going to stop at least 1 millimeter away from where I want to end up on all of these measurements. And then we'll start measuring from the top again once I do this all the way down. So I'll see you in a little bit. Okay, I stopped 1 millimeter short on all my measurements, and let's see, I just finished getting all the way down. The long measurement on the .001, I like to be 20 millimeters down. So let's see where we ended up here. 040, whoa, did he peel back? Might not, oh, yeah, that's 040. 080. Is down to 2, so this is going to be an open facing for me. I might have to remove some more table. 3, that's good. This should go down. 4, almost 4. He's a little high on the right side. And then this guy should go down to 4. Yeah. So it peeled back quite a bit. So I'll probably end up removing a little more facing, but let's just see how the how these feeler gauge ones went. 6 millimeters, that's perfect. That's what I want. 8 millimeters, that's perfect. It's amazing how much it peels back. 10 millimeters. 12, nice and square. Everybody's nice and square. Well, maybe I leave the mouthpiece open like this. A lot of people like a slightly more open mouthpiece than I do. So what I'm going to do, this is a critical one for me, is the what is this, 0.005. If he goes down too far, you can never get the sound to have a core, but he's going down only to 15 millimeters, which is perfect. And the 0.001 is going down to 19 millimeters. That's close enough. Good. So the next job is going to be paying attention to the inside. The way that the bottom of the baffle falls away from the tip, and as well as the tip opening here. So I will mount this guy in a vise and then identify what needs to be done, and I'll be back. The next step is to deal with the inside of the mouthpiece. This rollover here that you see was commonly used in more open facings, and I'm not really quite sure. I believe it provides enough resistance for a thin tip so that the tip doesn't get out of control. But on a closer facing mouthpiece, which is the style nowadays, it doesn't really make sense to have the rollover. It makes the sound shrill. I know one major mouthpiece manufacturer uses rollover, but that's because their window is too wide to get a focus sound, so they use rollover to increase the intensity of the high frequencies. Anyhow, I have a bunch of files that I like to use. This one here is custom made. I grind off the side so that if I'm working on the bottom of the baffle, I'm not risking scraping the side of the mouthpiece. And this little guy here is perfect for squaring up the edges. It's just a little teeny bit of abrasion on the end, but not on the sides or anything, so I can square up the sides, which is very important for good mouthpiece behavior. A mouthpiece that has any rounding along these surfaces here causes the pressure wave, when the reed compresses, to travel across the mouthpiece and up the other side and back up against the reed. Really what you want in a mouthpiece is a true compression expansion, where the compression results in just pressurizing the entire mouthpiece and no flow, if you will. And then this guy here is my persuader, and he's the one I use to remove a bunch of the material when I'm dealing with this amount of rollover. So I'm going to just show you what I do here. And you have to be very careful, because you don't want to expose any of the tip to abrasion. So you see what I'm doing here. It's just removing material bit by bit. And I'll continue like this until I'm able to get pretty much a straight shot going from the tip rail on down. And some mouthpieces even have a little concavity right after the tip. I don't see any benefit to doing that, but this is a standard V block used by machinists for holding round pieces when they're working in a lathe. And I like it for holding mouthpieces. So I'm going to continue like this, and I'll be back when I switch from filing to the sandpaper. The other thing I like to use are these, well, actually, I actually brought these to Everett Matson, and he was extremely excited. They're sold in assortments, Flex File. I think it's a company up in Canada, so they're probably expensive now. But then I found out that there's a whole industry of nail files for women that are manufactured. I'll pull an example out. The best manufacturer I've found so far is this Marquardt. And they have various different grits. And I end up cutting crosswise little pieces that I can stick a file in and put it inside the mouthpiece and move it back and forth to get very specific about areas that I want to remove. Okay, I've removed a fair amount of material with the larger one. Now I'm going to do some smoothing, get rid of the scrape marks. And I keep sighting down to see how much I've removed. Let's see. I'm not sure that this is really, you can see what's going on here, but at any rate, then one of the very handy files is also just a plain old needle file. So now, because I've removed that material below the rollover, if I use this, I can actually remove the material near the tip rail. And I go sideways as much as I'm going back in and out, so that you're averaging across and not digging a groove. Okay, so I see now I'm going to take my little flat shoe here and just work the edge. If the edge of the mouthpiece at the tip curves up too much, then you get resistance. So you got to make sure that that's not curling up too much. And then I take one of these little babies here, like this guy, and it's got a coarse side and a fine side. These little gouge marks are where I stick a file in order to manipulate the material. So I'll take that guy and put it here. I'm just averaging out everything. We'll use a smoother side. There's my wastebasket. Then, just so that I can see what's going on, this is like triple-aught steel wool. Just a light polishing here, just so I can visualize the edges inside. And so there, let's see, tip it this way, I'm seeing way too much of a rounded edge where the sidewall meets the bottom. So I'm going to work to square that edge up on both sides on the inside. And I do that using this little guy here, and also, it may seem a little crude, but there is a file I have that has a sharp angle. And I'll find it and come back. This guy. So he has a very sharp angle here that I'll use just to go down in there and remove a bit of that radius that I'm seeing inside here. I don't know how to illuminate this that you guys can see it, but anyhow. Not much. Don't take away a lot because you can't put it back. And now I'll use my little guy. This one here. you'll see that I have to get in there with my magnifiers to see what I'm doing as I do it. Hold it. I'm holding it flat against the side. There's no abrasion on the side, and I'm holding it flat against the side and pushing down. These are expensive Swiss needle files for working on, I think they use them for mold making. And this side is going to need some more serious work. So that's the side I've filed on the side. Good. It's looking good. And then if I tip it away a little bit, I'll average it into the chamber from the edge. And, and now let's see if you can see, but that's the sharp edge I'm looking for between the wall and the floor. So now I'm going to just take another measurement across the tip, and I'm seeing that we're a little high over here and a little high over here inside, so I'm going to work on that for a little bit just to get those to come down a bit, and then we'll measure the width at the tip and make sure that the window is the right dimension. So okay, my preferred file for this is actually a diamond file. It takes off very little at a time, and I'm going to see if I can find it. It's got a blue handle, which should be easy for me, but I'll come back. Red handle. This is the blue handle. That's a regular crosscut file. You have to keep wiping away the dust because it makes you think you're filing somewhere that you're not. Just seeing that dust. I'm smoothing out the surface of the tip here because it's got a flat bottom, so it'll take down the high spots. Okay. Stay there. Okay. All right, I'm going to be working with sandpaper here until I get this all smoothed out, and I'll show you the final result. Okay, so I've done much of the reshaping in here, and what I'm going to do now, let's see if I can show you this. It's a little bit of squaring up that's needed at the tip there. You see a little bit sticking into the window a little bit. So what I'm going to do is use this file here, which is called a knife file. It has a non-cutting edge here, and I will put that on the side here and take a few strokes to square that up. So I'm put on my magnifiers, and this I have to do carefully. And I might have to use some smaller files and sandpaper just to get that edge nice and square. So I'm going to use this guy. This is where the difference between a well-performing mouthpiece and a not so good performing mouthpiece is made, is right at the very tip. So I can see that I've removed just a little bit there, which looks good. Square it up. Okay. So now, before I bother play testing, I'm going to do one last check, and that is to make sure the contour of the baffle is consistent. So I use a depth gauge. Now that I know my rails are parallel, I can, here, I'll just scrape away the dust here. I set it to every half of a tenth of an inch, so 0.05, 0.1, 0.15, 0.2, and I put it in along the side, draw it to the other side while maintaining contact with the rails all the time. And it just creates a teeny little ghost of a line there. And I'm going to move this now to the 0.1 inch, lock it, go ahead, run it up along the side, and I'm hardly pressing down at all. It just creates like a pencil line. And I do this until I get to 0.5 inches. And what it does is it creates a bunch of contour lines, and I can look down and see if one side of the baffle is higher than the other or not. These old machine tools, measuring tools you can buy on eBay for a song now because everybody wants digital. Digital are great, except the battery always dies just when you need it the most. And these old guys, if you don't mind reading numbers yourself, rather than having them told to you, they work fantastic. And and are extremely accurate and will last you the rest of your life. For all I know, this did already last some mechanic or a machinist his life. This one's made by Starrett. Great ones are made by Mitutoyo and Brown and Sharp, various people. Okay, so now let's see if we can see this here. You can see that there are a bunch of curved lines in there, and if the line goes down sharply on one side, that means that is higher up than on the other side. And so I would need to file down on that particular side. There you can sort of see what I'm talking about. And so I'm going to examine this with my magnifying glasses, and it does look like the left side is a little bit higher than the right side. I'm not sure if you can see that from this, but you see that the curve is a little more on the left side, which means the left side's a little bit higher. So I'm going to work that down a little bit with various files and then re-smooth it and then come back to you. But basically, I can use this guy here, the convincer, and we'll just do some material removal. And I'm rolling always the file toward the middle. And then I will use this guy to get rid of the grooves. And then I'm going to use the sandpaper, and then I will come back to you after I've done the soundings, and we'll see what that looks like. See you in a few. Okay, so after taking away some material, those lines look fairly even to me. I don't know if you can see them or not. There. Anyhow, it's looking good. The tip opening, the window opening is 11.35 right now. I thought that by removing material on the sides, we would have gotten a little wider than that. Let's see. Something is wrong here. I'm going to go back for a 0. And then yeah, 11.2. So I'm going to spend a little bit of time widening the window by removing material from here and here. And the way I do that is I loosen up a little bit here. I roll the mouthpiece to the side. Let's roll this guy over here, just so I get a flat and square. I've seen some old mouthpieces come to me where somebody just filed at an angle to make the window wider, and that's it's not going to have the same effect. and then do the other side. And I'm going to do this back and forth until I get somewhere around 11.4, and I'll be happy with that. Again, this is a knife file that has no abrasive edge down below, so I'm not damaging the surface of the baffle. And I will be back once I see still way close to 11. All right, I'll work on this for a while. Before I play test the mouthpiece, I'm going to go ahead and do the cleaning that I wanted to do. This is a super fine abrasion here and a super fine polishing. So I do this under water. Water always improves any abrasion process. If you're doing reed work, always wet your file, your sandpaper file, before working on the reed. So I do this both in with the coarse and the fine, and I'll show you when it's done. Okay, I dried it off, and I put a little 1 millimeter thick pressure sensitive adhesive silicone pad. I punch these out. I buy this material at McMaster Carr. So I'm going to just, before I put wax on the outside to keep it from oxidizing again, we'll go ahead and restore the logo here and ligature lines by using this metallic gold crayon. And I'll do the ligature lines separately, but I'll just show you how they I go in two directions, across and then up and down, and then you take a wipe, and there it is, George Bundy. Now to go ahead and do the rest. So there it is with the ligature lines filled in, the number 3. And now what I'm going to do is I'm going to take some Renaissance wax, which is a microcrystalline wax that dries fairly instantaneously, and I'm going to wipe that all over this outside of the mouthpiece, and then let it sit for a minute, and then buff it off and be done with that. Okay, let's see what it sounds like and feels like on my Mo custom clarinet. It's a little open for me and a little bright. It's just a little bit too close up. The baffle is too close up in this region, and so I'm going to remove some of that and improve the sound a little bit. So when I took off a little bit on the inside to provide a little more freedom, the mouthpiece rakes back a little. And it's a give and take process. You have to then plane it down again in order to get the same opening that you want. But I think I've got it about there now. So this is one of the cheaper mouthpieces you could get back in the day, the French version, French rubber. bit of squeaky reed there. Sounds good. Oh, how high does it go? Goes all the way. I nearly forgot to show you the tuning after this was all done. Although no specific efforts were made, I'll just show you that these old mouthpieces still tune well. Hopefully you can see this. Okay, well, I'm still getting over this cold. I couldn't quite make it all the way down, but you see the F is flat, as they all are, but the rest are pretty much in tune. So, it is a keeper. Okay.